So the problem is this. From one point, one object goes to the right, starts, okay, at 3 meters per second it is sent. It is just fired at 3 meters per second. Okay. So another object is fired from here only to the left at 4 meters per second. Okay. So now these two objects actually are also under the uniform gravitational field. That simply means that they are actually falling in the gravitational field. It may not be working. So anyway, so 4 meters per second it is sent here, and 3 meters per second is sent in the opposite direction. They are also working on the gravitational field. There is a gravitational field which makes it fall also. Now, we know very well that because of the gravitational field, this will actually, one moment is in this direction, one moment is in this direction, and it will actually fall somewhat like this. Okay. And similarly, the other one actually will fall somewhat like this. Okay. And we know very well that this is slightly nearer than this one. Okay. If you take the central point, because this is 4 meters per second. Okay. Now, the question that is asked is, we want to find out distance between these two particles at the point at which their velocity vectors are mutually perpendicular. We want to find out when are their velocity vectors mutually perpendicular, and at that point we want to find out the distance between them. That is the question. So I want to today show it to you that it can be solved in 3 different ways. So whole idea is to learn these techniques. Okay, solving the problem is only a matter of consequence when you actually learn the techniques. Okay. So what I want to do is I will want to solve it using basically 3 different techniques. Okay. So let's first start with a very simple understanding of the problem. So the understanding of the problem is like this. If I want to write down, okay, the velocity vector for this at the point at which it has started, okay, its velocity vector I will call it as, okay, u, okay, initial velocity u, okay, u1 is equal to what? Initial velocity vector. Let us say we are going to take all the things that are towards the right are positive and towards the left are negative. Okay, and we will also take all the things up positive, down negative. Okay, that is our convention. We can take any convention we want. Okay, so we will take this convention. With that convention, we can write the velocity vector for the first one. This is the first object which is coming here. This is the second object. Okay, the first object, second object. So for first object, we will write it as 3i cap plus 0j cap. Okay, there is no vertical velocity to start with. Okay. So similarly, what will be the u2? u2 is minus 4i cap plus 0j cap. Okay. So horizontally, okay, horizontal velocity is remaining at 3 meters per second because there is no force acting on it. Okay, and here horizontal velocity will remain at minus 4 meters per second because there is no force acting on it. Okay, so in such scenario now, what will happen to the vertical velocity? Vertical velocity will not remain the same. Vertical velocity, because it is falling down, it will keep on increasing. In what form? In the form of v is equal to u plus gt. Do you agree? Vertical velocity will keep on increasing. What is happening here vertically? Vertically it is just falling like a free fall. Okay. Falling like a free fall actually simply means at any point of time we want to calculate vertical velocity is equal to, is given by the normal equation v is equal to u plus gt, because g is constant, g is constant acceleration. Okay. So if I want to write down velocity of the first particle at any point in time, okay, I will write it like this: 3 I cap plus, okay, in this place 0 plus gt, okay, but downward is negative, so I will write it as minus gt j cap. See whether you like it, whether it is agreeable. So 0 j cap is the beginning, that means j actually simply means vertical velocity. I is horizontal velocity, j is vertical velocity, okay, of the same body, of the same object. So do you agree that v1, which is considered as velocity at any point of the body 1, can be written as 3i minus gt? If anybody has a question, it is the time to ask now. Okay, I will write similarly v2 as minus 4i minus gt j. If you don't like it, you have to say it now. Okay. So the moment you write like that, okay, now we have defined exactly the velocity, complete velocity vector from here to here. All that time, what is its velocity, we have defined. Velocity vector, how it is moving. So velocity vector as a function of time we have written. If you keep giving different values of time, it will give on giving the velocity vectors at that point in time. T is equal to 2 seconds, after 2 seconds how is the vector looking like, that it will give you. Okay. So like that, at any point in time, what is the velocity vector, that will just substitute that point in time there and you will get to know. No, wait a minute. What I am trying to do is this, okay. The velocity here is v is equal to u plus gt, u being 0. This will be basically downward is minus, so I will call it as u. V value is nothing but 0 minus gt. I am substituting that 0 minus gt in this area and it has become minus gt, that is why. Okay. So now, once you have the velocity vector in place, okay, now we have to find out what is our question. Our question is, now when do these velocity vectors are equal? When are they, no, when are they perpendicular? When are they perpendicular? How do we find out when are they perpendicular? That is the question. Okay. Now, to be able to do that, we actually have 3 different techniques to do. Okay. Today I will teach you all the 3 techniques so that you will also learn the techniques. It is not just about solving the problem. Okay. The techniques are, one of them is trigonometry based technique. Second one is basically coordinate geometry based technique. And the third one is simple vector algebra. All the 3 we will now explore. Okay. So, let's start with the trigonometry first. Okay. Whenever we say 2 things are perpendicular, it simply means angle between them is 90 degrees. Okay. So assume that there is some point at which here and some point at which here. Okay. And if I actually bring that here and write it, the same thing if I write it here. Okay. So this angle should be 90 degree. I have just taken this vector and just moved it here just to show that this angle is 90 degree. Okay. So now to have this possibility, okay, if I write like this, okay, Now I can say that this angle plus this angle is 90 degrees. Okay. So I will call this angle as A and this angle as B. So for our work, for our scenario is angle A plus angle B is equal to pi by 2 or 90 degrees. Okay. So I'll write it 90 if you want. If you don't like pi by 2, we'll write 90. Okay. So however, what is angle A? Let us look at angle A. Okay. How do we calculate angle A? So look at this. This vector we know. Okay. What is this vector? This vector is 3i minus gtj. Okay. So that vector actually 3i minus 3 gtj actually simply means if I draw a line like this. Okay. Let me just draw slightly neater diagram. Okay. If I actually draw a line like this, this part from here to here is 3 and from here to here is gt. That is why it is 3i minus gtj, that vector. Okay. That vector is 3i minus gtj because this is 3 and this is gt. In x direction it is 3, in y direction it is gt. Okay. So if you want to find out what is this angle, then simply it is tan inverse of 3 by gt. Do you think so? Don't you think so? Any doubt on this? So tan of angle A is equal to 3 divided by gt. Do you agree? This is 3, hence this is also 3. This is gt, hence this is also gt. So that is basically 3 divided by gt. Now, what about B? Can I write angle B? Angle B is how much? Tan inverse of 4 by gt. So this is basically, since we are looking at only the angle, just the value of the angle, not the direction. We are adding that two values to get 90. It doesn't matter, basically it is minus or plus. This length divided by this length is we are worried about. Okay. This length is basically 4 and this length is gt. So this is 4 by gt and this is equal to 90. Can you solve this? So there is an equation with single variable called t. How will you solve this? So this is where trigonometry comes into picture. Okay. I hope you guys have studied a little bit of trigonometry at least. What is the meaning of tan theta, cos theta, sin A plus B, cos A plus B? Well, all those things I hope you know. Okay. That is required to solve this. See whether you can solve. 2-3 minutes you just try. I will solve anyway. What do we have to do? This is a single equation with the t being the single variable. Okay. So we can actually solve it for t and then we will come to know at what time it is 90 degrees. Very hard, no? So this requires a trigonometry. Okay. So I will just basically not use too many formulas. Okay. I will just use most of common sense and see whether it can be solved. Okay. So now A is what? Tan inverse of 3 by gt. Okay. So now first I will do like this. Keep it as A and B is equal to 90 first. Okay. Now I know that cos 90 is equal to 0. Do you know that? Okay. So since it is 0, I like zeros. Okay. So I will actually try to put cos on both sides. Okay. I can do anything to the left side, same thing you can do to the right side. Okay. So I will put cos of this. See, look at this. I am going to write this as cos of a plus b is equal to 0. Cos of a plus b is equal to cos 90, which is 0. Correct? Now, cos of a plus b formula, you guys know. Cos a cos b minus sin a sin b is equal to 0. Okay. Now, cos a cos b is minus sin a is equal to 0 means cos a cos b is equal to sin a sin b. Okay. So now, what is cos a, what is cos b, what is sin a, what is sin b? If we know that, we can solve this. Okay, look at this. Okay, we know that tan a is equal to, this is a triangle here, you don't have to worry. Okay, tan a we wrote it as 3 by gt, correct? So cos a you can write now what it is in the same triangle. This is 3, this is gt. Cos a is adjacent side divided by hypotenuse. So gt divided by 3 square plus gt square under root. Correct? Do you agree? Cos a is written as gt divided by 3 square plus g square t square under root. Can we write like that? So I have given you a technique now how to write this. Now please write it for cos b like that, sin a like that, sin b like that, and substitute it here and solve for t quickly. Okay, so the reason I am doing that like that is basically I wanted to show you how actually if you are given one particular angle and if you have a tan inverse of something, how do you get the tan inverse of cos of the same angle through using a simple triangle method. Okay, okay, we can actually take this as the statement as cos a cos b, will take it that side. 1 is equal to sin a sin b divided by cos a cos b. Okay, which is nothing but tan a tan b. Okay, now when you have tan a tan b, life gets very simple because tan a, okay, 3 by gt and this is 4 by gt, so which is nothing but 12 by gt. Okay, so this way also if you do, you will end up giving you will end up same thing. Okay, this is basically 12 by g square t square. So this way also you will end up the same thing. Okay, now what did you get? G square t square is equal to 12. So t square is equal to 12 by g square, or t is equal to root 12 by g. So you got a value of t at which they are actually perpendicular. Okay, once you got that value of t, now finding out the distance at that time, that point basically you get a little bit of physics. Okay, so now look at it. When both of them are actually traveling, like one at 3 meter per second, one at 4 meter per second, at the point after, let us say, t is equal to root 12 by g seconds, after that, okay, now my question to you is whether these two will be at the same height or will be at the different height. correct? They must be at the same height at the same time, because vertical component actually is same for both of them. Both are accelerating in the same way. It is like asking two things: if you drop like this, they will always simultaneously fall. Okay. So the distance between them actually simply depends on only this horizontal. Okay, horizontal component remains 3 and this side it remains 4. So in 3 meter per second after root 12 by g, how far it went? Like that, that's all. Distance is equal to time into velocity. So just calculate. So now you calculate now at t is equal to root 12 by g seconds. Okay, how much will be the distance between them? G you can take it as g itself. Okay, 7 root 12 by g or correct 14 root 3 by g, correct. So distance between them, distance is equal to 4 root 12 by g plus 3 root 12 by g, which is equal to 7 root 12 by g, or which is equal to 14 root 3 by g. So you have two vectors here. One is v1 is equal to 3i minus 3g, v2 is equal to minus 4i minus 4g. Okay. So there are two of them here. One is this vector, another is this vector. Okay. Now this is actually like a this is like straight line for us. This vector is a line. Okay. For us, and once you have a line, you can find out the slope of that line. Okay. So if this line and this line, both of them, you can find out the slope. And what in coordinate geometry, if two lines have to be perpendicular, their slopes product should be equal to -1. Okay. If two lines are perpendicular, then product of their slopes is equal to -1. This is a coordinate geometry, one of the rules for the lines. When they do lines for you, they will tell you this. Mostly in 11th it will come, or maybe I don't know, 10th only some people would have studied. Okay. So if two lines are there and if their slopes, if you multiply, okay, and if it gives -1, then that means they are actually perpendicular. That is the rule. Okay. Now let us find out the slope of each one of them. Slope of the first one. So slope of the first one is what? Minus gt divided by plus 3. So while doing the slope, we have to be careful about getting the minuses, because we are into the coordinate geometry world. Okay. M1 is equal to minus gt divided by plus 3. Okay. This y by x part. Okay. So then M2, slope of this is, if you look at it, this is actually minus gt divided by -4. So we have to have M1 into M2 is equal to -1. Okay. Substitute this and tell me what is the value of t. Now what is important is that the fact that whenever somebody tells you perpendicular, okay, what are the things that comes to your mind? Whenever you say perpendicular, angle should be 90, that should come to your mind. Once that comes to your mind, wherever the angles are there, find the equations for them, add them and equate it to 90 and you get an angle. Idea. Okay. Second thing, whenever somebody says perpendicular, suddenly what comes to your mind is slopes product should be -1. See whether you get the slopes and multiply them and get -1 and see whether you can solve it. So now let's go to the third one. Okay, third one actually requires vector algebra. Okay. Now once you get the time, getting the distance, you know it is 6th standard maths. Okay, that we don't have to do. Okay. Okay. So now I will show you the last part, vector. Okay. So in vectors actually there is an important point that you have to understand. Whenever two vectors are perpendicular, okay, their dot product is 0. Okay, that means if two vectors are perpendicular, okay, then their dot product is 0. Okay. So what is the meaning of dot product? Okay. So if you have a vector called A, okay, is equal to, let us say, A1I plus A2J, and vector B, let us say, is equal to B1I plus B2J, then dot product A dot B is a scalar. Okay. Though vector A and vector B are vectors, dot product is a scalar. Okay. So if it is a scalar, it means it doesn't contain I and J and all those things. Okay. So the answer to this is, I will take these two, A1 into B1 plus A2 into B2. That's all is defined as a dot product. Okay. Or there is another method which is called as A dot B, can also be defined as modulus of A into modulus of B into cos theta, where theta is the angle between them. That is another method. If somebody has given you an angle between them, then you use this method. If somebody has not given an angle, then if they have given directly the vectors like this, then you can use this method. Okay. So we don't need to find the angle. Okay. So what we need to do here is simply find the dot product and find out, equate it to 0. Sorry, equate it to 0. So A1 B1 plus A2 B2 equal to 0. That's all we have to do. So that means 3 into minus 4, V1 dot V2 is equal to 3 into minus 4 plus minus GT into minus GT is equal to 0. Okay. So minus GT into minus GT is nothing but G square T square again. This is minus 12. So you are back to the same question, same thing. T is equal to root 12 by G. So once you get T, calculating the distance between them is again a 6th standard mathematics. Okay. So now we understood basically 3 different ways of doing this problem. Okay. So what have we learned? Okay. We have learned a few things. What is, first of all, remember this. Now whenever you have done a problem, if whatever you have learned, you tabulate somewhere down after the problem. These are the things that I have learned. Next time you have to use them whenever you are doing a next problem. Okay. So whenever we say two vectors are perpendicular, so what are there are 3 different conditions we can use to get the equations. Okay. One of them is angle sum is equal to 90 degree. Okay. Second one is product of the slopes is -1. Third one is dot product is 0. Okay, dot product of two vectors, if it is 0, then they are perpendicular. Okay. So with these three things we learned. We learned a few more things too. That is, whenever, okay, two things are falling, whatever may be the horizontal velocity, vertically actually they are always at the same height. That we have learned. Okay, vertical falling is dependent on just GT. Vertically and horizontally has no relationship with each other. Whatever may be the horizontal, vertical remains to be like a free fall. That is another thing that we have learned. Okay, and one more thing we learned is how to do some trigonometry. Okay, trigonometrical equations how to solve.